Hello, in today's session, we are going to continue on with our discussion of Chapter 10. This is Part 3 in the Chapter 10 note series, and we will introduce the concept of molar volume. So let's review the things that we already know about moles. In the first session, we had discussed molar mass. Molar mass has the units of grams per mole, and it tells you how many grams are in 1 mole of each substance. This is a value that is unique for every substance, and you can calculate it by using your periodic table. The second thing that we established about moles was Avogadro's number. Avogadro's number is 6.022 times 10 to the 23rd. This number is important because 1 mole of any substance will contain 6.022 times 10 to the 23rd representative units. Yesterday, or in the last video, we had discussed what representative units are. The representative unit varies depending on what substance you are talking about. If you have 1 mole of an element, you would say that you have Avogadro's number of atoms in that mole. If you have 1 mole of an ionic compound, you would have Avogadro's number of formula units. If you have 1 mole of a covalent compound, you would have Avogadro's number of molecules. Today, we are going to discuss molar volume. Molar volume says that 1 mole of any gas at STP will occupy 22.4 liters. It doesn't matter what the gas is. It could be oxygen, it could be air, it could be carbon dioxide, it can be nitrogen, it could be methane. Anything, as long as it is at STP, will occupy a volume of 22.4 liters for every 1 mole of gas. But what does this STP mean? STP is an acronym standing for standard temperature, not temperate, my bad, temperature and pressure. The temperature that is considered standard is 0 degrees Celsius, which is the same thing as 273 Kelvin. Pressure at its standard is 1 atm, or 1 atmosphere. Now, pressure isn't something that we have discussed much yet in Chemistry 1, so that's kind of unfamiliar to you perhaps, but atm is the standard unit that we use. So 1 atm, or 1 atmosphere, is standard. 1 atmosphere is the same thing as 101.3 kPa, and kPa stands for kilopascals. We will discuss pressure in much more detail in Chemistry 2 and work with that quite a bit. But just to give you some reference points, 0 degrees Celsius is the freezing point of water. 1 atmosphere would be the pressure of the air around you at sea level. So let's take this new concept and let's apply it. The review and sample problem that I've chosen for us today starts with this. Calculate the molar mass and percent composition of methane, which is CH4. So to find the molar mass, remember you must list out what elements you have. In methane, you have carbon and hydrogen. According to the formula for methane, there is 1 carbon and 4 hydrogens. Next, we pull out our periodic tables and look up the molar mass of each of these elements. Carbon has a molar mass of 12.01. 1 times 12.01 is 12.01. If I look up hydrogen on the periodic table, the mass of hydrogen is 1.01. 4 times 1.01 gives us a value of 4.04. To find the total mass of methane, I must add those two values together, which gives me a value of 16.05, and my unit label would be grams per mole of methane. We are also supposed to determine the percent composition, so I must find the percent that is carbon and the percent of this compound that is hydrogen. To find the percent composition, you take the total mass of that particular element. In this case, carbon has a total mass of 12.01, divided by the total mass of the compound, which is 16.05, and we multiply by 100%. So if you take out your calculator, you take 12.01 divided by 16.05, multiply by 100, I get a value of 74.8% carbon to find the percent that is hydrogen, I must take the total mass of hydrogen, which is 4.04, divide it by the total mass of the compound, multiply by 100%. When you plug that into your calculator, you should get a value of 25.2% hydrogen. Remember, the way that you can check yourself is all of the percentages should add up to 100%. So 74.8 plus 25.2 does give you 100%. So those are the correct values. Now, to take this and change it up a bit, our next question says, what is the mass in grams of 3.5 moles of CH4? We will begin with the number and unit that we are given in the problem. So 3.5 moles of CH4. We want to convert from grams to moles. So if I take a look back here, do I have a way to get from grams directly to moles from either molar volume, Avogadro's number, or molar mass? I do. Molar mass tells me exactly how to go from grams to moles. So I am going to put one conversion factor here. I am going to put moles of methane in the bottom and grams of methane in the top because I want to get rid of moles and go to grams. Yesterday we had discussed that you always put a 1 next to the mole side of these factors. 1 mole is the same thing as how many grams? Well, if we look back at our last problem, we calculated the molar mass of methane. We said that there are 16.05 grams in every 1 mole of methane. So I will use that here. I'm going to put 16.05 grams is equivalent to 1 mole when you're dealing with methane. On your calculator, to solve this, you will begin by plugging in the 3.5, since that's the number we started with. I should multiply by 16.05 because remember, you always multiply by the top number in the factor and divide by the bottom number. So 3.5 times 16.05 gives me 56.2, and I need a unit label of grams of methane. Excellent. Another problem. What volume does 4.7 moles of CH4 occupy at STP? We are going to start with 4.7 moles of CH4. I am trying to get to volume. Remember, volume is measured in liters. So I'm trying to go from moles to liters. I have to go back and take a look at my options. Can I go from moles to liters? Do I have a link? Well, molar mass relates grams to moles. Avogadro's number goes moles to atoms, moles to formula units, moles to molecules. Molar volume goes from moles to liters. Aha, just the link that we need. And molar volume says 1 mole of any gas at STP will occupy 22.4 liters. So if I go down here, I can complete this in one step. I'm going to put moles of CH4 on the bottom because I want to get rid of that, and I'm going to put liters of CH4 on top. We always put a 1 with the mole side, and molar volume says since we're at STP, 1 mole is the equivalent of 22.4 liters. On my calculator, I will begin with the 4.7 that I'm given, and I shall multiply by 22.4 to get my answer. When I do that, I get an answer of 105, and my unit label would be liters of CH4. I hope that this tutorial video, along with reading section 10.2 of your textbook, will help you to better understand how you can convert between grams, moles, liters, atoms, formula units, and molecules. Our newest tool that we have learned today, remember, is that 1 mole of any gas at STP will occupy 22